it used to be simple. There used to be only one kind of function in JavaScript. Now we have two kinds of functions. It's something that was added to JavaScript at a later date. We have classical functions, the original functions in JavaScript, and now we have arrow functions. So what's the deal with that? Why do we have two kinds of functions? Well, let's take a look. Let's do a comparison between arrow functions and classical functions. Let's compare. Why do we even have two kinds of functions, right? Well, we're going to look at some similarities and some key differences between the two. So, all right, let's take a look. Okay, so two different kinds of function expressions. Now, yeah, I am actually adding this word. I'm not just saying there are two different kinds of functions. There are two different kinds of function expressions, because actually, if you look deep down under the hood of JavaScript, functions are functions. There are no different kinds of functions, really. But there are different kinds of function expressions. That's actually what these things are. What I'm calling classical functions, first of all, the original kind of function in JavaScript. Classical functions, basically functions declared with the function keyword. And then arrow functions, the other kind, well, these are expressions. Okay, these are not functions in memory, but these are expressions in the code, and that's an important distinction. So, what are we looking at really? Well, I mean, the first thing you notice is this function keyword right here, right? I don't even need to look at the rest of this code sample. I see right away that I have something that starts with the function keyword. So I know that this is a function. I know that it's actually a classical function expression because of that. Well, let's jump down here to the arrow function. Instead of a function keyword, we still actually do have an identifying symbol, and that's the arrow symbol. So yeah, the arrow symbol, it's actually an equal sign followed by a greater than sign. But together we call that this arrow symbol, and we see it's right there. Now, definitely one thing to notice right away, the arrow symbol is not at the beginning of the expression. So right away we have a difference in syntax. This is just a syntax difference where when you're reading code and you see the word function, well, when you see that keyword, well, you know that right there, where that keyword is, that's where a function expression is starting. With an arrow function, not exactly the same, right? Like here, the arrow is actually buried deeper into the expression. But I want to point out that in terms of the elements of a function, well, we actually have the same things. And these two examples, this first function above here, I called it getLastLetter. So it takes a name, it takes a string really, and I just wrote a function that returns the last letter of that string. And then I did the same thing with the arrow function syntax. So these are actually two identical function expressions. They do the same thing. And let's look at their component parts. After the function keyword, what do I have? I have the name of the function. So I decided to name this function getLastLetter. If I look down at the arrow function, what do I see? Well, it turns out that I also see the name of the function in here. Okay, so that part is present in both. Now, what do I have after? Well, here, right after the name, I have, between round brackets, I have the list of arguments. In this case, I have one argument. It's called name. Do I have this? Yes, I do have this in the arrow function. It's right here. Okay, so far so good. I'm seeing the similarities, the similar components. And now I actually have the inside of the function. Well, in my classical function, I have a return keyword followed by an expression which really does the work of my function, right? This expression right here. Is it present in the arrow function? Yeah, look at this. This is the exact same expression. All right, so that's it. I mean, I'm just identifying the components here, the parts, and I see that they are present. I see some things are different. I mean, for one thing, I see right away that the arrow function is shorter. It's on one line. So that's a difference. I also see that I have this thing at the beginning. I have const. So I know that const is used to declare a variable that doesn't change, it can't get reassigned. It's a const variable in JavaScript. So I don't have that when I'm using a classical function. So we'll see about that just in a second. But ultimately here at the end, I can use this function in the exact same way. In whichever expression I'm using, whether it's a classical or an arrow function, I use it the same way. I call it, and I'm going to get, in this case, I say get last letter hello. What am I going to get as a result? I'm going to get a string which is the last letter, which is O. So that's pretty straightforward. Now, let's go deeper. Okay, 2 similarities and 2 differences. I picked out 2 similarities to talk about. But the thing is, there are actually many similarities because under the hood, we are talking about JavaScript functions. That's both of these kinds of expressions produce functions, and those functions, once they're created, basically whichever method you use to create a function in JavaScript, it's going to be a function that can be completely equivalent. So it's like there are more similarities than differences is what I'm saying. But I picked out 2 similarities, and we're also going to look at 2 key differences. So similarity number 1, and I like to talk about this aspect because sometimes we forget. We forget about the fact that these functions are actually, we're talking about expressions. And that's my similarity number 1. Classical function expressions and arrow function expressions are both types of expressions. They're expressions. So, why do I stress this? I like to talk about expressions a lot because I really do believe that they are one of the fundamental building blocks of understanding JavaScript. So why do I talk about expressions in this case? Because here are some things about expressions. These are things that are true about expressions. First of all, expressions can get evaluated. So when JavaScript runs your code and it comes upon your function expression, it evaluates that expression. That's what happens to an expression. That's number 1. Number 2, when they are evaluated, expressions produce a value. That's really the goal of an expression, is to produce a value as a result. That's what evaluation actually means. In the case of function expressions, the value that is being produced is a function. And that is a similarity between classical functions and arrow functions. Specifically, actually, I'm talking about those expressions while they produce a function. Okay, so they are expressions, they produce a function. But I want to dig a little bit deeper. So I'm going to tell you about similarity number 2. It's just going a little bit more specific. And I want to say this. Classical function expressions and arrow function expressions, what do they do when they're evaluated? They create a new function. Okay, so this is kind of important because, there are all kinds of expressions that can, as they get evaluated, produce a function. Not just function expressions, because you might have functions that already exist and they're in a variable or they're in an object. So those are expressions that can produce a function, in other words, return a function as a result, so to speak. But only function expressions create a new function. And in fact, they do that every time they get evaluated. So that's something that's in common between classical function expressions and arrow function expressions. So just to point out what's going on, I want to show you the arrow function expression here, where, as I said, we have this const in the middle, and we have a name. Well, we know what this is, right? If you've declared variables in JavaScript, then you know that this is a variable declaration where we have a variable name, we have the const keyword, and then we have an assignment. So this equals sign is actually an assignment operator. So this whole area on the left is not specific at all to a function expression, right? That's just a variable declaration. So this part on the right, all of this is the actual arrow function expression. And it is the part that creates that new function when it is evaluated. So just for emphasis, here I copied that very same arrow function expression just to isolate it and say, hey, this is actually the arrow expression. And this is the part that creates a new function. When we were talking about this part here, this equal sign, well, that is actually just outside of the arrow function expression. That is just an assignment that we're doing into this newly created variable. Okay, well, on to some differences, because this is where we can find some more insight about what these expressions really are. And one thing about classical function expressions that you notice pretty soon as you start using them is that they can accept a name. So inside of a classical function expression, you can have a name of a function. You can name it, but this is optional. You don't have to name this, and you don't have to name classical functions, basically. This is the name right here, right? So this is the optional part. But the entire function expression is an expression, so it's, we could actually even still assign it to a variable. So that's why I'm saying this is optional, because if you don't do this, then nothing will happen. But if you do give it a name, then there is a side effect. I like to call it a side effect because it happens regardless of what the expression evaluation produces. Regardless of that, there's a side effect that happens where if you provide that name, then the classical function expression will assign the function to a variable with that name. So in other words, it actually does what this does, right? As I just reproduced the same example from the last slide, this part where with arrow functions, we have to sort of explicitly say, okay, I'm going to take the result of this expression and I want it to be assigned to this variable. That's how I give it a name, really. That's how I can give a name to an arrow function expression. But with classical functions, I have this mechanism where I can provide the name right in there after the function keyword, and it's going to kind of go behind the scenes. So we don't see a const, we don't see an equal sign as an assignment operator. It just goes behind the scenes and it does that for us. And again, it's a side effect because the expression still produces a function as the value. Okay, so difference number 2, and this is probably the big difference that is the most deliberate, basically. When arrow function expressions were added to JavaScript, this was a big deal because this was kind of almost enough to justify the entire existence of arrow functions. And it's the value of this. So the value of this. So this is like, what is this? It's a keyword. It's kind of acts like a variable, and it's the source of a lot of confusion, unfortunately. So this is one of those features of JavaScript that maybe introduces more confusion than it really solves, than it helps. But this is, it happens to be the key difference between classical functions and arrow functions. And this is how I like to think about it. Now, it's kind of tricky because how do you describe exactly the difference in simplest terms? Well, here's my attempt to try to boil this down in the simplest way possible. Classical functions, they determine the value of the this keyword. They determine it at the moment when they are called. So when you call a function that was defined as a classical function, at that moment, it's going to determine what value will be held in the this keyword. Arrow functions, on the other hand, they basically say, I'm not even going to care about the this keyword. I'm going to pretend that it doesn't even exist, that it doesn't affect me. And so they keep the value of this from the location where they were created. Now, another way of thinking about this is that they don't touch the value of this. They let it pass through them. Whatever the value of this is, in the place in the code where the arrow function is, that's the value that it'll have. So there's no strange determination that happens, which is what happens in the case of classical functions, when the function is called. It doesn't try to go and determine what value of this is going to have at that time. All right, so I mean, what do I mean by that? I mean, I'm going to try to give you an example here, a bit of a contrived example, but what do I mean by the fact that the value of this depends on how the function gets called? Well, let's look at this example, and then let's actually look at it from the bottom. How does it get called? Well, that's what this last line is. This is a function. In this case, we could call it a method because it's a function that's part of an object here that's being called while it's attached as a property to an object. And so when this happens, when this kind of call happens, well, the value of this, is going to be what's on the left, basically, right? When we call getName, we know that inside of getName, we're going to have the value of this that comes from the left here. What do I have in this object? I have my function getName that I just called, right? And it's going to return this .getName. So that's why I'm saying, okay, the value of this, well, it's going to be person because that's how it is called. Now, so that's a simple enough example where all you need to know is when you call this method with an object, when it's called, that's when we're going to know, well, when it's going to determine what the value will be for this. Now, example number 2, and I tried to put together an example to illustrate almost the same thing, but with an arrow function which doesn't care about the value for this. And to illustrate that, I actually changed very subtly here. Instead of getName, I now have a function that doesn't return the name, this.name. So let's see, it returns, instead of returning this.name, it returns an arrow function. This is an arrow function that has here no arguments, and then the body of the function is, well, it returns this.name. Now, how would we use this? Well, instead of just returning the name, we're now returning a function which returns the name. That's why I called it getNameGetter. The function that we're returning from this function is a getter. It's a function that gets that name. The point is that now we have a function where when we call getName, it was actually defined by returning it from this function here, which has a this inside of it. Now, when I call getName, notice that there's nothing in front here, right? There's nothing in front to provide a value for this. But that's okay. We don't care because the arrow function actually just preserves whatever the value is of this where it's defined. So it's defined here. I mean, I drew a green box here, but it's defined here. That means it's just going to take whatever value of this it has when that gets called, when this arrow function expression gets evaluated, which produces an arrow function. So maybe this isn't the most simple thing to explain with a small example, but suffice it to say, the shortest way to sum it up is with arrow functions, the value of this is just inherited from where the function is created. It's just going to take the value of this and pass it on. It doesn't care about how the function is called. That's it. All right. Let's recap that. Okay, so recap. 2 similarities that I talked about, which is really, the 2 similarities that I talked about are really about the fact that these function expressions are expressions, and that when they get evaluated, they create a new function. That's really what they are. That's, you could say that function expressions are function creators, okay? Now, 2 differences we talked about. The key differences, and it kind of brings us to this question. I wanted to bring up this question. So why were arrow functions added? Why were they added to JavaScript? I mean, we already had classical functions. So at some point, the authors of JavaScript, so to speak, because there's more than one author, and they're not just the authors, they're the people who maintain and keep up to date the specifications for JavaScript. At some point, they decided that it was worthwhile to introduce arrow functions into the language. Why? Why add something to the language? What does it solve that wasn't already possible with classical functions? Well, nothing. It doesn't solve anything that wasn't possible. Arrow functions don't add anything new that wasn't possible to do. But they do two things, and I think these are, maybe I agree that arrow functions really do make life easier for you as a JavaScript developer. So first of all, number one, what's the number one reason they were added? I'm not sure if this is the number one as in the most important. Maybe they're equally important. But number one, because they can be shorter to write than classical functions. And so this comes into play when you're using functions a lot. When you're using a lot of small functions, it can get tedious to have to write them with the function keyword. And arrow functions, well, they don't actually even need a return keyword either. They can implicitly just return the result of one expression. So basically, they're a lot shorter, a lot cleaner looking. And yeah, so when you do that a lot, when you use a lot of small functions, then that's an advantage. It leads to much cleaner code. And we definitely know that, in JavaScript, we have a tendency typically to use a lot of functions, often functions which we pass into function calls. And often they are small functions when we're using what I would call functional programming style. That's really a style of programming that uses a lot of relatively simple, relatively small functions. And number two, why? Because they conserve the value of this. And, in other words, it actually allows you to forget about the this keyword if you don't need to worry about it. And that's a nice advantage, right? It means you don't have to always remember what is the this keyword doing, like where is it getting its value. Okay, with arrow functions, we can breathe a little bit. If you don't need to use this, then you can kind of forget about how it works. Obviously, if you are using the value of this, then, you still kind of should remember how it actually works and where it gets its value. But definitely arrow functions allow us to not have to be bogged down with that aspect of the language. And that makes it a lot easier. It just makes it a lot easier to pass functions around. It makes it a lot easier to return functions from other functions. And that makes everybody happier, right? That makes us JavaScript developers happier. Cool. All right. Well, you've been watching JavaScript with Marek. If you enjoyed this video and you want to get more content from me, go to javascriptwithmarek.com and subscribe to my email list there. And the other thing that you can do to get more content from me is to subscribe to my channel, and you'll get updates. So thanks a lot.